Hey everyone! Welcome to our video on operating system management. Today, we're diving into the 5 important OS managers that make sure our computers run smoothly. Buckle up as we explore the world of OS managers. These are the 5 operating system. Process Manager, Memory Manager, File Manager, Device Manager, Network Manager. First, let's talk about the Process Manager. Its function in the computer is to manage running programs by handling CPU scheduling, multitasking, and process synchronization, ensuring efficient execution of tasks. Let's take a look at the Process Manager using this table. It plays a crucial role in handling multiple programs at once, ensuring smooth CPU scheduling, efficient multitasking, and proper process synchronization. Here's how it works step by step. P1 Process Creation. The OS starts a new process when a program is executed. It assigns a unique process ID PID. P2 Process Scheduling. The OS decides which process gets CPU time using scheduling algorithms like FIFO, round robin, or priority scheduling. P3 Process Execution. The CPU executes the assigned process. The Process Manager ensures smooth operation without conflicts. P4 Process Synchronization. If multiple processes need the same resources, the OS synchronizes them to prevent deadlocks. P5 Process Termination. Once a process completes, the OS removes it from memory to free up resources. Now, let's take a look at the Process Manager. The CPU chip at the center represents processing power, while the floating task windows and performance graphs show how the OS manages tasks, allocates CPU time, and ensures smooth multitasking. Now, let's take a look at the Process Manager. The CPU chip at the center represents processing power, while the floating task windows and performance graphs show how the OS manages tasks, allocates CPU time, and ensures smooth multitasking. The circuit lines show how processes communicate with the system, while the futuristic neon design emphasizes high-speed computing and efficiency. These are the functions of the Process Manager in an operating system, ensuring efficient CPU utilization, smooth process execution, and system stability. Each function plays a crucial role in managing tasks, optimizing performance, and preventing resource conflicts. CPU allocation. The Processor Manager is responsible for allocating the central processing unit CPU to various processes. Process tracking. It maintains a record of the status of each process, where a process is defined as an instance of a program's execution. Monitoring CPU activity. The Processor Manager checks if the CPU is actively executing a process or waiting for read or write commands to complete. Managing transitions. It handles the transitions of processes from one state of execution to another, similar to the role of a traffic controller. Setting up resources. Upon allocating the processor, it establishes the necessary registers and tables for process execution. Processor reclamation. When a job is completed or reaches. Next, let's talk about the Memory Manager. Its function is to ensure that programs have enough RAM to run efficiently while preventing memory leaks and optimizing system performance. Let's take a look at the Memory Manager using this table. It plays a crucial role in managing system memory, ensuring efficient allocation, virtual memory handling, and memory protection. Here's how it works step by step. M1 Memory Allocation. The OS assigns memory space to programs when they are executed. M2 Memory Tracking keeps track of which memory locations are in use and which are free. M3 Virtual Memory Management. If RAM is full, the OS uses a portion of the hard drive swap space to store inactive data temporarily. M4 Memory Protection prevents one process from accessing another process's allocated memory to ensure system security. M5 Memory Deallocation. When a process ends, the OS frees up its memory space for other processes to use. Let's take a closer look at how the Memory Manager works. This illustration visually explains how a computer handles memory allocation between RAM and virtual memory. On the left side, you can see the RAM physical memory section, where active applications like Google Chrome, Microsoft Word, and Spotify are running. However, RAM has a limited capacity. Once it gets full, the OS needs a way to handle excess data. That's where virtual memory swap space comes in, as shown on the right. The OS temporarily moves inactive apps, like background processes or unused Chrome tabs, to free up space in RAM for more important tasks. This group of responsibilities falls under functions of the memory manager or key responsibilities of the memory manager, ensuring efficient memory allocation, optimal resource utilization, and system stability. Each function plays a crucial role in managing memory space, preventing conflicts, and maintaining overall system performance. Memory management. The memory manager oversees the allocation and management of main memory RAM. Validation of requests. It checks the validity of each memory space request and allocates unoccupied memory if the request is legal. Multi-user tracking. In a multi-user environment, the memory manager keeps a table to monitor who is using which sections of memory. Protection of OS memory. A crucial responsibility is to protect the memory spaces occupied by the operating system, ensuring they are not altered or tampered with. Memory deallocation. The memory manager is also responsible for deallocating memory when it is no longer needed. Next, let's talk about the file manager. Its function is to organize, store, and manage files efficiently while controlling access permissions and ensuring data integrity. Let's take a look at the file manager using this table. It plays a crucial role in managing files and directories, ensuring efficient storage, access control, and organization. Here's how it works step by step. F1 File creation. The OS allows users and applications to create new files and assigns metadata: name, size, type, permissions. F2 File storage organization. The OS organizes files in directories/folders and manages file locations on storage devices. F3 File access permissions. The file manager controls who can read, write, or modify files through access permissions. F4 File read-write operations. The OS retrieves data from a file when accessed and updates it when modified. F5 File deletion recovery. When a file is deleted, the OS removes it from the directory and marks the space as available. Let's take a closer look at how the file manager works. This illustration visually explains how a computer organizes, stores, and manages files and directories efficiently. The File Explorer window is structured with multiple folders and files, indicating an organized directory system. Various file operation icons such as create, open, move, delete, and rename are displayed, highlighting essential file management functions. A storage drive icon symbolizes where files are stored, ensuring accessibility and organization. Additionally, user access control icons read, write, execute permissions emphasize security, determining who can interact with specific files. Lastly, a trash bin icon is present, representing file deletion and potential recovery options. The clean, modern old design illustrates how the file manager plays. The set of duties falls under roles of the file manager or core functions of the file manager, ensuring effective file organization, secure access management, and efficient resource distribution. Each responsibility is essential for handling file storage, preventing unauthorized access, and sustaining overall system efficiency. File tracking. The file manager maintains a record of every file in the system, including data files, program files, compilers, and applications. Access control enforcement. It enforces predetermined access policies that restrict who can access specific files. User permissions. The file manager controls what actions users can perform on files, such as read-only access, read and write access, or the authority to create and delete files. Resource allocation. The file manager controls what actions users can perform on files, such as read-only access, read and write access. Next, let's talk about the device manager. Its function is to ensure that all hardware devices are properly connected and communicating with the system while managing resource allocation and optimizing device performance. Now, let's explore the device manager with this table. It is responsible for handling hardware components, ensuring seamless device detection, driver management, and efficient communication with the operating system. Here's how it functions step by step. D1 Device detection. When a new device, for example, USB, printer, keyboard, is connected, the OS detects it automatically. D2 Driver installation. The OS checks for the appropriate device driver and installs it if needed for proper communication. D3 Resource allocation. The OS assigns necessary resources, for example, memory, ports, for the device to function properly. D4 Device communication. The OS enables data transfer between the device and system, ensuring smooth operation. D5 Device monitoring control. The OS continuously monitors the device, managing power settings and resolving conflicts if needed. Let's explore how the device manager operates. This illustration provides a visual breakdown of how a computer coordinates hardware components, manages device interactions, and optimizes system performance. This illustration represents device management in an operating system, structured into 3 layers. At the top, the operating system oversees all device operations. The middle layer features the device manager, which acts as the control center managing communication between hardware devices and the OS. At the bottom, various hardware components like a monitor, keyboard, mouse, printer, USB storage, and speakers are connected to the device manager. Arrows indicate the flow of communication, showing how the device manager detects, installs drivers, allocates resources, and ensures proper functioning of devices. The set of duties is categorized under functions of the device manager or key responsibilities of the device manager, ensuring seamless hardware integration, efficient device communication, and system stability. Each function is vital for managing connected peripherals, preventing hardware conflicts, and optimizing overall system performance. Monitoring role. The device manager oversees all devices, channels, and control units in the system. Efficient allocation. It selects the most efficient method to allocate system resources like devices, printers, ports, and disk drives according to a predetermined scheduling policy. Resource management. The device manager allocates each resource, initiates its operation, and upon completion, deallocates the device, making it available for the next process or job. Lastly, let's discuss network management. Its role is to ensure seamless data transmission, maintain network stability, and optimize resource utilization while preventing congestion and security vulnerabilities. Now, let's explore the network manager with this table. It is responsible for managing network connections, ensuring seamless connectivity, IP address management, data transmission, and network security. Here's how it functions step by step. N1 Network detection. The OS detects available wired or wireless networks, Wi-Fi, Ethernet, Bluetooth, etc. N2 IP address assignment. The OS assigns or obtains an IP address using DHCP or manual configuration. N3 Connection establishment. The OS establishes a stable connection with the network, ensuring authentication and encryption if required. N4 Data transmission. The OS manages data packets, ensuring they are sent and received efficiently over the network. N5 Network security. The OS enforces firewalls, VPNs, and encryption to protect against unauthorized access and cyber threats. Let's dive into how network management functions. This illustration provides a visual breakdown of how networks regulate data flow, allocate resources, and maintain stable connections for efficient communication. Network management is essential for maintaining secure and efficient communication between devices. The illustration shows a central server linked to computers, routers, and switches, representing the core of a well-structured network. Elements like shield icons for cybersecurity, graphs for performance monitoring, and alert symbols for troubleshooting highlight key aspects of network administration. This image emphasizes the importance of managing networks to ensure smooth operations in modern IT environments. These responsibilities are part of the key roles of the network manager or essential functions of the network manager, focusing on maintaining network efficiency, securing data access, and optimizing resource allocation. Each task plays a vital role in ensuring smooth connectivity, protecting against cyber threats, and enhancing overall system performance. Role of Network Manager: manages the network aspects of operating systems, enabling resource sharing among users. Resource sharing facilitates user access to shared resources including hardware like CPUs, memory areas, printers, tape drives, modems, and disk drives. Software access allows sharing of software resources such as compilers, application programs, and data files. Access control controls user access to these resources, ensuring secure and efficient usage. Thanks for watching. Keep exploring the world of technology. We hope you learned something new. See you next time.